First we're gonna teach you series, and we're not messing with theories, so listen to us clearly. Next we'll teach you sequences, so listen up, math fetuses. A series is a sum, to addition you must succumb. A sequence is only commas, so now there's no drama. Geometric or arithmetic, although they're both synergetic. Arithmetic is addition, geometric multiplication. I might sound a bit abrasive, but now we're talking about recursive. A base n equals r times a base n minus 1. The r equals what's repeated. Isn't that fun? Remember to give a base 1. Explicit is even more fun. A times r to the n minus 1. Explicit is great because you can just plug n in and you get the answer. What a win. Now summation is with series. We're going to appease your inquiries. Let's go first with finite ones. These are cool because they always have a sum. Here is summation notation. Plug it into your calculator. It sure is a good answer generator. Or you can use this equation, but for me to do this, it takes some persuasion. Now let's move on to infinite. It sometimes works, but there are some limits. You can only find the sum when r is less than 1.
So we know this is a geometric sequence because it is being multiplied by a common ratio of 2. And so right now we're going to learn about the explicit formula. So how you're going to do that, you're going to do a base n, and that equals the first term, so a base 1, which is 2. And then you multiply that by r to the n minus 1, and the ratio is 2 to the n minus 1. Now say you wanted to find the sixth term, so the next term, a base n equals 2 times 2 to the sixth minus 1. And so a base n equals 2 times 2 to the fifth. Then you get 2 to the sixth, which equals 64.
So using the same sequence from the past numbers, we can write it in recursive. So the r is the common ratio, which in this case is 2. And then you have to write a base 1, which is the first term, which in this group of numbers is 2. There you go. The reason that recursive forms are not as helpful as explicit forms is because to find the nth term of any given sequence or series, you have to have the previous term.
Okay, so to find the sum of a finite series, what you can do is you can take the number of terms that you want to find the sum of, and you put it into the sigma notation, which is 8 in this case. And so then you take the first term, which is 2, and you put it in the equation, and you take the common ratio, which is also 2, and you put it into this equation, and then you can put it into your calculator. But what you can also do to do it by hand is you can use this equation. So using this equation, it would be a1, which is 2, and then the common ratio, which is 2, and then again 2 over here, and then n is the number of terms, so it would be 8, and then you can solve that to get the answer.
So this is an infinite series, so you have 1/3 plus 1/9 plus 1/27 dot dot dot, because it doesn't end ever. So here's the sigma notation. So you have, so the a1 in this case would be 1/3. And r would also be 1/3 because that's the ratio going being multiplied with 1/3. But you would not change n because it's infinite, and you're not. Well, you would change it over time, but it's infinite. And in order to find the sum of it, you have this equation here. Originally we put something else in our wrap video. That was wrong. This is the actual one. So the sum of the infinite series is equal to a sub 1 divided by 1 minus r. So you'd again change this to 1/3. And you would change this one also to 1/3. And plug this into your calculator and you would get the final answer.